This segment is Chapter 11 from our Management Information Systems text. It is on business intelligence and knowledge management software. So we began talking about data warehouses and the term business intelligence. So a data warehouse is a large database that contains both historical data and other data. The data warehouses by themselves are not useful. To make a data warehouse useful, organizations must use software tools to process the data from these huge databases into meaningful information. The data warehouse itself can be seen as a mine where the useful information is the precious metals that are found from it. Now, business intelligence is the meaningful information that is gotten from the data warehouses. So organizations must use software tools to process the data from these data warehouses into useful information. Because executives can obtain significantly more information about their customers and suppliers and other organizations, they like to call this information business intelligence. This is the meaningful information that businesses are getting, and it is also sometimes called business analytics. So data mining is the process of selecting, exploring, and modeling the large amounts of data to give us the useful information and discover the relationships that are visible in that data. Data mining software searches through the large data looking for meaningful patterns so that we can summarize and analyze the data and make business decisions from it. While some tools help find predefined relationships and ratios, they do not answer the questions that the more powerful data mining tools answer, which is, what are the relationships that we do not know? Some of these tools require the investigator to determine which relationships the software should look for in the first place. Other tools use more of an artificial intelligence technique, and they try to discover the relationships that we do not even know existed yet. So for example, if we said discover the two products that would most likely sell well together on a weekend, that latter query is asking the software to find the patterns that otherwise would not be detected through observation. Some experts say that we are letting data mining answer the questions for us that we did not know to even ask. So the combination of data warehousing and data mining techniques make it easier to predict future outcomes based on the patterns that can be discovered in that historical data. You can see we've used data mining in a lot of fields. Fraud detection, targeted marketing, and marketing are big examples of when these data mining techniques are utilized. So data mining has four main objectives. Sequence or path analysis, finding patterns where one event leads to another. Classification, finding where certain facts fall into predefined groups. Clustering, finding groups or related facts not previously known. And then forecasting, discovering patterns that can lead to reasonable predictions. Data mining is especially powerful in the marketing area because many businesses are trying to shift from a mass marketing of a product to a targeted marketing to individuals with a variety of products that would likely satisfy that user. We call this term marketing to one. Data mining techniques can be used to try to predict which customers are more likely to buy our products in the future, and therefore allows us to target that marketing toward them. Some common market data mining applications include consumer clustering, identifying the characteristics of the customers who tend to buy the same products and services from your company. Are your products typically purchased by women? Are they typically purchased in the downtown area? Maybe they're typically purchased by someone in the age category of 40 to 50 and less likely to be purchased by a senior citizen who was, say, 70 or 80. And so you would need to change your marketing strategies to go after those type of characteristics that you have identified your consumers as having. Customer churn tries to identify the reasons customers switch from one competitor to another. They want to be able to predict which customers are likely to leave and why. I typically get a lot of questions if I leave a company as to why am I leaving? Why am I not going to do business there anymore? What happened that led to that? Because companies are very concerned about this. It's way more expensive to get new customers than to keep their existing ones happy. So if they have consumers or customers that are constantly leaving their services, then that's going to make it harder for them to earn a profit going forward. Another method is direct marketing, identifying the prospective customers that we should include in our mailings or email lists so that we can obtain the highest response rate and make those mailings more cost effective. We also see data mining being used in fraud detection. So identifying the characteristics of a transaction that would make it most likely fraudulent. Internal auditors and fraud auditors, as well as external auditors, can utilize some of these data mining techniques, looking at a company's data, trying to ensure that there is no fraud. There are certain transaction behaviors that we can look at as far as the numbers that are in the transaction amounts and things like that, that can make it more suspicious of fraud, and we would want to check into it further. So data mining is used in banking to help us find both profitable customers, but also to look for patterns of fraud. We can also use some of these other techniques that are listed, such as the market basket analysis. What products are going to be purchased together? And that is one way they market to us on a lot of websites. When we add something to our cart, we'll all of a sudden have 3 things pop up or 4 that say, these are some of the things that people who purchased what you just did also purchased. Maybe you should look at those. And so that market basket analysis is being done to find those patterns. What are people buying together? Trend analysis will reveal the differences between a typical customer this month and a typical customer last month. So if this month my typical customer was spending $200 and next month my typical customer is only spending $100, I might want to know what is causing that difference. Is the economy starting to create scare for people, or is there some other reason? And so we can look for those trend relationships, the trend analysis. So data mining examples in use. You can see that we try to predict consumer behavior. Banks are again looking for fraud. With mobile phone services, we help determine a factor that affect customer loyalties. We might do surveys to say, why haven't you stayed with this company? Is it our customer service? Is it our network coverage? What are the things that are keeping you here? Many companies have been creating customer loyalty programs. You see these at almost every grocery store. We go into Kroger and we swipe our Kroger card, and oftentimes we do this to get discounts. Many times the memberships are free. Usually they're free. And oftentimes we're using them to get discounts or, rewards in some way, fashion for going into that store. The biggest benefit for the store is, number one, it keeps customers coming back because we know we're going to get those discounts. So I do think that helps also. But the customer has a steady flow of customer data. Whenever I go in and I swipe my card at Kroger, they have a record of every item I purchased. And so now they know which coupons to send me, which sale items to target toward me to get me to come back into their store and buy from them and not someone else. Amazon is very big at using a lot of data mining. It's probably the biggest one. They are constantly looking at the demographics of their customers, the issues that people have about why they didn't want to buy online. One of the biggest deals was shipping. So I think that is one of the things that led to Amazon Prime, is customers oftentimes would rather pay a single fee up front and not have to pay shipping for every item that they get. I know personally for us, it means that when we need something, we go to Amazon a lot of times before we go other places. If we don't have a specific thing that we're looking for example, I get my face cream from a special store. So, I'm not going to go to Amazon to look for that product. But if I'm trying to buy picture hanging supplies, I'm going to go to Amazon before I go someplace else, because I know I can get Prime and I get the shipping already paid for. So they look for these trends. What are the problems? What are the good things that are going on? And then they figure out who's buying from them, what are they likely to buy, and they can really target their marketing efforts toward that. Online analytical processing is a type of application that is used to exploit the data that we've got stored in these warehouses. It sometimes is considered faster than many other approaches to pulling the data out of there. It might not be as sophisticated in the terms of the analysis conducted, but it has an extremely fast response time, and that allows executives to make very timely decisions. Now, OLAP managers see summaries and ratios of the intersection of two dimensions in the database. So it does allow us to see those summaries and ratios. They are sometimes explained as virtual cubes of information that the user can rotate and view the cube from different angles and see the different pieces of information in different relationships. Drilling down is a process by which we start with the table that shows broad information and successively retrieve tables with more specific information. So the OLAP application lets you receive information on the number of employees and as their percentages in each region, department, etc. It composes tables on the fly based on your desired relationships that you've specified. OLAP applications oftentimes are used with relational databases. A dynamic OLAP application will respond to commands by composing tables on the fly. And to speed up the response, the databases are organized based on these dimensions. So you have dimensional databases that are sometimes used with OLAP. And in these dimensional databases, in addition to storing the detailed transactions, they also store the information in summary and ratio format so that we do not have to wait for that to be calculated. So the difference between a traditional database, a transactional database, and a dimensional database is the transactional database only is storing the transactions. It does not store the summaries or the ratios. Those have to be calculated every time. OLAP applications are usually installed on a special server that would communicate with both the user computer and the server or servers that contain the data warehouse or the dimensional databases. They are often considered to be faster than SQL in using their queries. Because they are designed to process large amounts of records and produce summaries, they are usually significantly faster than most relational applications such as SQL or structured query language queries. OLAP applications are increasingly used by corporations to gain efficiencies. Employees who know very little about programming and report design are discovering that business intelligence software is becoming easier to use. Intelligent interfaces are created, allowing us to enter a question in free form or very close to the way we would say the question, and then they're able to interpret that and get us the answers we need. The BI semantic layer is a part of the application that parses out the question that you ask and translates it into instructions for the computer to access the appropriate data and produce the answer in usually showing charts and trends. BI software has become so popular in large companies that Microsoft has integrated such software into their powerful database management system, SQL Server. They also have a tool called Power BI, which is similar to some of the tools that we used for data intelligence in Module 11 in Excel with the Power Queries. More customer intelligence. Why do companies want to integrate their CRM systems with the OLAP or the data mining tools that they are using? There's a major effort in almost every business to collect a lot of data about their customers, to learn who their customers are and why they are their customers. Both data mining and OLAP software are often integrated into our CRM systems so that we can better analyze those relationships. Since an increasing number of transactions are being executed through the web, managers can use the data that is already in an electronic form to analyze and strategize their business moves. The challenge is to address the right customer at the right time with the right offer instead of spending millions of dollars in mass marketing and covering numerous websites and television ads and so forth with advertisements. So with that in mind, with the effort toward the targeted marketing, it is more important than ever that we are capturing those relationships that data mining gives us by analyzing our CRM systems data. Clickstream software. So companies are keeping track of what you do when you go on their website. They don't want to know just what did you buy. They also want to know what did you look at? How long did you look there? How many items did you add to the cart and then remove from the cart before you actually checked out? They want to consider, why are you removing some of these items from the chart or the cart? Why didn't you buy them? If you left their site and left something in your cart, why didn't you check out? Did you forget? Or did you change your mind? They want to know all of these types of trends. So they're not just tracking what did you buy. They are tracking everything we're doing on their website. So this software that tracks this is called Clickstream software. It tracks and stores data about every visit to their website, including which site did you go to their site from, which items have you clicked on, how long did you view them, did you look at reviews, did you look for additional features, what all did you do when you were looking at their site. The data can then be analyzed to help redesign the site to make your visits more attractive and more efficient. So if you notice that 90% of the customers that look at one product then connect to another product and look at it, well, maybe you should make that connection an easier transition to where when you click on one, the other one pops up down in the bottom for you to click on automatically if you choose to. Things like that. The purpose is to have the visitors spend more time at the site so that its potential for advertising revenue for the company grows, and possibly we entice the visitors to make more purchases. Many companies find that using only the data collected directly from the consumers does not provide that full picture. I may have looked at 25 different things and only bought one. What made me not buy the other 24? That's almost as important to the site operating company as the fact that I bought the one product. Is why didn't I buy the other stuff? There are companies such as DoubleClick and Engage Software that are hired to study these consumer activities. So we can track it ourselves, and we can also hire other companies to track it. These other companies, when we hire them, they are using cookies and spyware to collect consumer data. And then it's combined with the individual's company's clickstream data to give us more analysis as to what the consumers are doing. Spyware has been grown to have a negative connotation associated with it, but remember, it does not mean they are doing it with a malicious intent. So these companies, yes, they are spying on us, and yes, many people feel that that is an intrusion of your privacy, and they provide ways to try to block that. But the company is not maliciously trying to harm you. They're trying to figure out for their client, what do you buy? What do you want? What was missing in the things that you didn't buy? Why didn't you look at those? And things like that. By compiling billions of consumer click streams and creating behavioral models, the companies can determine consumers' interests, the frequency, the times that they surf, and the number of times they click on ads or complete a transaction. So Amazon has been a very successful example of utilizing a lot of this clickstream data to better market to their customers. And a converted customer is a shopper once they are convinced to buy. So, I may have a customer that keeps coming out to my site, but if they never buy, then I need to be analyzing those transactions as well to figure out why do they keep coming back but not buy. Dashboards are another key topic that we hear about a lot right now. These systems used to be called executive information systems. And some of the key things that they had to have is they had to be very easy to learn and use, because executives did not want to have to spend days or weeks trying to figure these systems out. So they had to be very intuitive. They had to give them quick summary information. They didn't want to have to weed through all the data looking for the trends. They just wanted to see the trend. So companies are now creating what's called dashboards. So dashboards is the new term for what was previously called executive information systems. So the dashboard is, first of all, an interface. The interface means how does the user interact with the computer. The interface is trying to make the business intelligence tools more convenient for the executive. Again, the executives do not have days and weeks to figure out how to use these. They're trying to run their companies. They want a very quick way of assessing the viability of their company and how it's doing. The BI tools create these interfaces that help executives and other employees quickly grasp their business situation. So these are becoming more and more commonly used in organizations. With the expansion of the use of big data and business intelligence analytics, these dashboards are becoming more and more popular. They get their name because they kind of look like a car dashboard. They have information in graphs or scales or dial type indicators telling the user very quickly, visually, what the indicators are in their company. They're usually built off of key performance indicators, the things that are the most important for that company. So maybe one of them is how many days their customers are taking to pay that buy on credit. So I want to very quickly see, are my customers' days to pay? Is that going up? Are they taking longer or are they taking shorter? What is the trend? What is that value going to? And so these are very quick ways to see specific key performance indicators and what the trend is in that indicator. So when we implement these dashboards, it's important to view these key performance indicators as the data is being captured. I don't want to see today what was happening 3 weeks ago or a week ago. I need to see what's happening today. So dashboards are designed to quickly present those predefined key performance indicators based on current, up-to-date data. So for a hotel or a hospital, they might use occupancy rates. For another business, they might use inventory turnover. For a customer call center, they might use customer hold times as a key performance indicator. But it's whatever they feel the strategic initiatives are in their company that lead to success. And it provides them a quick and easy way to get a read on how those indicators are performing. Knowledge management systems are mainly to gain a second type of knowledge. So it's a combination of activities involved in gathering, organizing, sharing, and analyzing knowledge to improve our performance. For knowledge, there are two types. First, knowing what you want, and then second, knowing where to find the information about that subject or knowing how to get the information. The first type of information, knowing about a subject or knowing what, can be taught. The second type can only be learned. Information can be gleaned from stored data, and then it becomes knowledge. So the attempt by organizations to put procedures and technologies in place to transfer individuals' knowledge into these databases so that other people can have access to it. So if you think about knowledge-driven organizations like consulting firms, they rely and operate on the expertise of their employees. But as these employees retire or change jobs, that information can be lost. So then we try to set these systems up to capture that individual's information or their knowledge into this database so that instead of losing it, it can be captured by others who need it in the future. The book does give us a parable to illustrate this point. It says, one day at a factory, the production line came to a screeching halt. The manager called his trusty technician. The technician walked around the machine and hit it a bit, the machine line a bit, tapped it once with a hammer, and then the production line jumped back to life. The technician handed the manager an invoice that read $1,000. The manager said, $1,000? But all you did was tap it once, and the technician took the invoice and revised it to read, tapping the hammer, $10, knowing where to tap, $990. So much of what we need to be able to capture for these companies is knowing where to tap, not the fact that you tap. Okay, so knowledge management systems are an attempt by organizations to put these procedures and technologies in place to first transfer individuals' knowledge into these databases, filter and separate the most relevant knowledge so that we can access it effectively, and organize the knowledge in the database to allow easy access by other employees. As the cost of storage media continues to decrease, database management systems are increasingly more sophisticated and affordable. So as the tools improve and the storage improves, it becomes easier to try to use these techniques to capture the knowledge and into a knowledge management system so that we don't lose that information as our employees leave. So a research company, IDC, argued that almost half of the work that is being done by knowledge workers, so those that prepare and provide information for someone, has either been already done or at least partially already done. So I'm creating something and someone else has already done that. It is estimated that labor worth $3,000 to $5,000 per knowledge worker is wasted annually because those workers are trying to solve a problem that has already been solved. If we can transfer our knowledge into these knowledge management systems, we can eliminate a lot of that cost. The advantage to these approaches is that these knowledge tools will mine unstructured data to build a profile about each employee and their knowledge, and then others can use that database to gain access to information that will help them with their jobs or look for similar expertise that they need. You know, it makes me think of LinkedIn in a broad sense. You know, when my husband has a project that he needs to work on and he knows he does not have the expertise, he does not set out to try to learn everything there is to know about that particular project tool. He goes to LinkedIn and he searches for someone who has that knowledge already. And he tries to bring in a partner, someone that he can work with, to bring that knowledge to the table without him trying to recreate it over and over again. And then finally, auto-categorization. To categorize knowledge into manageable data, companies use this type of software. It's also called automatic taxonomy, and it divides the data in these knowledge management systems into categories so that we can find the things we're looking for in the future. It makes me think of when I work with organizing my files on the computer. If I just put everything in one big lump and didn't have any categories for them, then trying to find something I needed in the future would be very challenging. These tools create the categories for me and group my data in this knowledge management system so that perhaps if I'm working on a project for let's say a manufacturing client that does job costing manufacturing, it can search through and find those topics that relate to that job costing and bring those forward for me to retrieve and see if it's information that I would need. So it's a way of categorizing and grouping the knowledge in that knowledge management system so that it improves the amount of information we can get and how quickly we can get it. And that concludes Chapter 11.